Co2MPRISE projects are projects of excellent science. The objective of this project is to develop the research, the science, through international exchanges between members of different sectors, such as the academia, the industry, and the commercial sectors. These international exchanges will improve the knowledge and the expertise of the members, and it also builds links between different organizations or different sectors.
The Co2MPRISE project is a project devoted to the control of carbon dioxide emissions. Power plants burn fossil fuels, coal and natural gas, most of them, and they emit carbon dioxide to the atmosphere. So what we are trying to do is to develop new materials for capturing carbon dioxide in order to avoid emissions to the atmosphere. We are using a combined experimental and theoretical approach. We are doing studies in the lab, but also molecular modeling studies, doing experiments in supercomputers to find the most suitable materials allowing economical and technological capture of this kind of materials. This is the objective of the project, to develop a new technology for capturing carbon dioxide at low cost with environmentally friendly materials.
One of the main challenges that the scientific community is facing nowadays, and which is also a key pillar for Horizon 2020, is to reduce the levels of CO2 emissions from the industry and the public transport, the civil transport. The methods that we have currently are not so efficient, so the objective of Co2MPRISE is to find new solutions to this problem, developing new materials that can absorb the CO2. To do this project, we come with different partners from all around the world, from Italy, from Spain, from Greece, and from South America. And they have different expertise in different fields, such as modeling, nanosafety, or synthesis of new materials.
The ICCRAM Research Centers provides to the Co2MPRISE project new research in both fields, in experiments and in theory. We are doing in silico screening of new materials, which means that we are studying the properties of the materials in supercomputers using theoretical methods in order to predict the properties, to predict the affinity for CO2, the ability to capture the material, and to find the most suitable atomic and molecular combination. Trying to find which atom, which molecules increase the capturing ability of CO2 at the lower cost. In this way, what we do is we start from a large number of compounds and we find those combinations with best properties. After that, what we do is we develop these materials at laboratory scale in order to confirm the experimental results. So we combine experimental and theoretical studies for starting from a large matrix of possible compounds to find the most suitable solution in terms of cost, decreasing the cost of capturing, which is the main problem with the current technologies, with lowest environmental profile, using materials with low pollution ability. We don't want to change one problem with other new one. We want to capture CO2, but with materials which can be produced from natural sources. So in this way, we try to find the best solutions starting from large matrices of compounds. This is our apportation to this project.
The specific role of the toxicity and biotechnology area of ICCRAM in Co2MPRISE is to study the safety of the new materials developed in Co2MPRISE. To do that, we study the possible toxic effects that they have using different model organisms. We will use human cell lines and the yeast Saccharomyces cerevisiae.